Hello, welcome. My name is Christine Perret. I'm the chair of the AREA Research Committee, and I'm very happy to be hosting today's webinar on the subject of the Khronos Group's AR and 3D commerce initiatives. Look forward to hearing these presentations and then facilitating an interactive discussion towards the end of this webinar. Unlike our normal webinars, this will be a 90-minute session because we have so much interesting information to share with you. During this next 90 minutes, you will be in listen-only mode. However, all attendees have a questions console as part of their GoToWebinar control panel. So if you can find that, you can add your questions at any time through that feature. And then at the end, when we have our panel discussion, we'll be happy to take those questions that we receive and hear how our experts reply. So for today's webinar, I'm going to start off, as I often do, introducing you to the area and explaining a little bit about the program that we have here focusing on interoperability and standards. We'll have approximately an hour's worth of presentations, and then, as I mentioned, panel discussion and take your questions. So I think that some of you may be aware of the AR for Enterprise Alliance. We are accelerating in the growth of an ecosystem, and I like to think of this pyramid of an ecosystem where on top are the enterprises. Very often they are companies that are risk averse. Oh, I am not sharing my screen. That's a problem. So to resume, thank you for joining me. And the enterprise AR ecosystem is composed of some enterprises, many enterprises, typically very large enterprises in risk averse industries. And they have complex products or services, and their employees find themselves in situations that they need some support, and AR can be of assistance and very valuable to their performance. Supporting the enterprise are the provider segments of the ecosystem and the non-commercial entities. Both of these segments support by providing new services, technologies, helping the enterprise to integrate and implement their the technologies necessary for augmented reality. The non-commercial entities also have a role to play in the research as well as in establishing policies and so forth that are related to the successful deployment of enterprise augmented reality. One of the things that the AREA has been doing with its members is studying how, where are the bottlenecks? What are the problems that AR can address, the kinds of problems that need to be overcome in order for AR to be widely adopted. So we created this schema of customer needs, and we've implemented this in a web set scenario. And what this slide shows you is just the variety of different settings and use cases where AR could be useful. And based on the top four segments of this schema, we can see that there are two important requirements. The first one of which is that the customer is facing some challenges because they can't get all of the technologies they need for good business operations and AR from one vendor. They are going to be always encountering a multi-vendor scenario, and they want to be able to use a variety of different solutions, different hardware, different software, and without having to do special engineering. And they need to be able to use the existing data and IT infrastructure that they've already perfected and invested in without additional headaches, cost, or time. So these two requirements really point to there being the adoption of standards and at least open interfaces between components and between companies and data sets. That's why we created the AR Interoperability and Standards program, to increase people's awareness about interoperability and what are the different approaches to achieving it. And finally, then to put together and to perform programs, to execute programs, of which this webinar is one. Our programs are all focused on addressing barriers to interoperability. We do not ourselves develop standards or open source content. However, we want to promote those that exist. And some of that is through creating thought leadership content, studying the requirements of our customers, as I showed you in the schema of needs. And then we also want to go follow that process through to ultimately even implementing or having some of our customers implement specifications in products. So it's a journey. There is not just one standard, it's actually going to be a suite of standards. And we want to partner with many different organizations at different levels in the stack. I'm very pleased to announce today that the AREA has established a liaison with the Khronos group. We had a good working relationship before, but now we have a formal liaison, and together look forward to many programs and projects where we can accelerate the adoption of open and interoperable augmented reality. So that's what I'd like to share with you for background as a way of introduction. And now I'd like to invite our first speaker, Martin Enthed. Martin, I've just made you presenter. Can you confirm if you have that?
Yes, I have, and I'm gonna share my screen, and you should see something. Okay.
Yes, we see you. Thank you.
Okay. So I'm really happy to be invited to this, and all my friends here from the Khronos groups. I will start off presenting from an IKEA point of view, from one of the retailers that has joined Khronos, and then the other guys will follow and mainly talk about what we do there. So I will start out. So my name is Martin Enthed. I work as a digital manager within IKEA. I've been there for about 14 years now, and started with computer graphics 30 years ago. So I've been in this for a long time. So let's start. IKEA. Our vision is actually to create a better everyday life for the many people. Not many people know that, and the reason why I stress that is that the important part here when we talk about standards is to reach many people. That's really the reason why we are so interested in standards at all. And when it comes to computer graphics at IKEA, we have been using that for many years. It's a central part of what we do. It really started back in 2005, where we started using, the idea came to start using computer graphics to create images. If you're more interested in just this topic, then you can use this QR code and find a presentation that is much longer. And that will take you through all these years about doing different things when it comes to computer graphics from an IKEA point of view. But super, super short, we use it to create images like this that we show to customers, fully computer generated. And the reason why we need it is that we are present in almost all parts of the world. And in all parts of the world, you don't have gas hobs, you have electric hobs sometimes, and you have other things. So you see these exchanges, all of this is made in the computer. So, but if jumping over to AR, what you see on the right is things that we have been doing for a fairly long time now. And what you see on the left is what we normally talking about an image, and an image, you know, says more than 1,000 words. But what if that image wasn't an image? What if that image was actually a 3D model? Yeah, then it says more than 1,000 images, and it will tell you stuff and information much faster than any other media I know. Like, humans are three-dimensional beings. And from what we have seen, nothing beats a 3D representation if you have three-dimensional information to give around a thing of any kind. So when did we start then? Yeah, we start with marker-based AR in the catalog app back in 2012. And here you see some news around that and how we used it. So you place the catalog on the floor, and then you use that to make the thing work. So you use the catalog as a marker. And then we started working internally a lot about trying to make a web representation look good enough. So here you see our internal test cases of trying to do things in WebGL in 2014, long before there were standards around this. And one of the main problem with this was that we had to maintain it. We had to figure out our own backends for it. We had to figure out our own like file formats and everything, and that was too costly and time consuming, so we very fast stopped doing this. Then we released IKEA Place, and IKEA Place came just because of ARKit from Apple. And the big difference between the marker-based AR and what's possible with ARKit and then AR Core from Google was that you got the size very, very correct compared to when you did marker-based. And what you could do then, you can actually then make things like this not happening in people's homes, checking out size and making it place it in an environment so it actually works. And this was a huge step forward. But the biggest problem has been there for a very long time. And we have been talking about this with the 3D industry all the way since 2012, 2013, when we started talking about it at the first event we were ever at. This was SIGGRAPH, a big graphics event that happens every year. And what we did back then was presenting that we felt that we were in the middle of a lot of big industries. We were in the middle of film, and we wanted film quality. We needed game speed, like interactivity. We were using a lot of CAD data to be able to get our data in, and all our things are living in an architectural space, but nobody really looked at the problems we had, or still, to be honest, have. And one of the biggest problems, one of the main hurdles to pass, is that we need a generic material description. And this is the old presentation, so it's really from 2013. What we said back then, we wanted the generic material description, and we would like to translate that over to different renderers so we could get this color to work everywhere. If I would say this today, I would say that I would like to have one surface appearance like this one, that then would travel over to the different renderers and the different applications that we do. Another thing that we really would like to figure out is an open standard for connectivity and combination. So if you have these kind of objects, how do you describe it so it becomes that in a generic way that everybody can understand? So for IKEA, we have been doing things when it comes to AR since 2012 and done virtual reality things, internal and external, all the way since 2015. And then we have a huge amount of editors, planners, configurators on the web all the way since 2002. So we are doing a lot when it comes to 3D. What we think will happen now is something that is actually much bigger than the mobile device revolution. Because the mobile device revolution was going from the stationary computers over to handheld devices that were personal and mobile. But the data into this and out from this device is approximately the same that from these. But it's personal and it's with you all the time. When we are going into spatially aware devices, when we are actually being able to show in AR to a person, a human, where a thing fits into the three-dimensional space, and that device also understands the three-dimensional space you're in, then we can do so much more. But to be able to do that, you have to have 3D. And what we are working a lot with now is to have an integrated product development pipeline. So you take all the things that you normally do in CAD and get it over to one physically correct asset. This should be fairly okay because we are mainly working in 3D when we are doing it, but unfortunately it's not so connected. And these are things that we are working heavily on. It should be possible, but it's really hard to do. Then you have this path down here when we have the products that you normally are not so good at doing in CAD. And this is also a very big thing that we are putting in a lot of time into, trying to figure out how to handle this part. And we have about 50% of our products in this area and 50% in this area. And then we would like to take that physical asset and get that out to different use cases. Using GLTF or a format and probably different file sizes and different compressions to be able to do and fulfill the different needs. So what we normally do, the simplest use case would be showing a product like this, the Fracta bag. But instead of showing an image, you show it in 3D. And this is actually a GLTF model running inside PowerPoint. So I'm just using a standard tool from Microsoft and showing a product from IKEA. And then you can do crazy stuff like this to get attention, or you can make it come up really close to the camera, and you can see things that you normally can't do otherwise. But to be able to do this in volume on any platform, IKEA needs a standard to use for 3D. And there really hasn't been anyone before June 2017 when GLTF 2.0 was announced from Khronos. And IKEA just joined just 3 months later in September 2017 into Khronos. And the main reason why we did that was because of 3D formats. And I won't talk a lot about 3D formats because we have other people here who will talk more about that, probably Neil and the others. But the reason why we're here is because we're planning and trying to do physically based rendering, so it looks correct. We also were part of starting 3D commerce, and the main reason for us to be in 3D commerce is that this group works with trying to make a compelling and consistent view of 3D, so it looks the same. So we don't have to make different versions of a 3D model because we're going to go to different channels. And a year ago, we actually also joined Khronos board as IKEA because we are super interested in everything virtual, augmented reality, parallel computing, neural networks, and vision processing that all the other areas in Khronos are doing. And I think maybe Neil will mention it at least later. So going back, we think that spatially aware devices going from 2D to 3D will be coming during the next 10 years. And when it does, we would like to be able to show our customers things in three-dimensional space because that is the easiest way to convey a message. And even if all of this started like 15 years ago when it comes to computer graphics, IKEA thinks that we still are in the beginning of this change. And as our founder always said, det mesta är nu gjort, underbara framtid, or in English, most things still remains to be done, a glorious future. So that was the introduction from my side, and I would like to leave over to Neil.
Thank you, Martin. That was excellent. We understand the benefits that IKEA can enjoy by participating in the process and adopting the standards. Neil, I believe you've been made presenter.
Great. Hey, yep. Hi, Christine. Do you see my screen okay?
Hi. Perfect.
Great. Yep. Hi, everyone. I'm Neil Trevett. I work on developer ecosystems at NVIDIA for my day job, but I'm also president of the Khronos Group. And firstly, I wanted to thank Christine and the AREA for organizing this great event and opportunity to talk. And we are excited for Khronos and the AREA to be working more closely together under our new liaison just announced yesterday. So I'm going to give a brief update on Khronos standards for augmented reality, in particular, the new 3D Commerce Working Group that Martin has been discussing, and why we think the efforts at that group are relevant to everyone working in AR. So, but if you haven't met us before, Khronos, we're an open standards consortium that is a non-profit organization. We're open to all, and all our standards are royalty-free for the industry to use. Our focus is on enabling applications to access the power of 3D graphics, virtual and augmented reality, and parallel computation. Last year was our 20th anniversary, and we have almost 160 members from around the world, from the largest companies through to small startups. And here are some of the Khronos standards that are most relevant to the augmented and virtual reality community. On the left are APIs and languages for parallel computation, including OpenCL and OpenVX. They're used for sensor and vision processing, which often includes inferencing for a better understanding of an AR user's environment. On the right are 3D rendering APIs, including Vulkan and WebGL. On the top are the initiatives we'll focus most on today around 3D asset formats, including GLTF and 3D commerce. And at the bottom is the OpenXR API standard for portable access to augmented and virtual reality devices. Today, we're going to focus primarily on GLTF and 3D commerce, but I want to spend just a minute or two giving folks here the latest updates on OpenXR and the new embedded camera API exploratory group, because I think they are hopefully relevant and interesting. So the Embedded Camera API Exploratory Group is Khronos's newest initiative. We announced it, in fact, just over a week ago. And it recognizes that there is a potential standardization gap in the industry for an API to control the increasing variety of cameras and sensors that are used in embedded markets, such as autonomous vehicles and industrial automation, and of course, augmented reality systems. And while Khronos has multiple open standard APIs for accelerating the processing of a sensor stream, there are no widely adopted cross-vendor standard APIs for controlling cameras and other sensors to actually generate those sensor streams. And this means that for many companies now, the cost and time needed to integrate new sensors into embedded systems has become a major bottleneck, both on innovation and efficiency. And this is becoming even more important as companies increasingly need to preserve their software investment across generations of hardware and cameras and sensors. But we're not jumping right into designing a new camera API right away. As a first step to address this problem, we have teamed with the European Machine Vision Association to use our exploratory group process to bring together as wide possible an industry quorum to explore whether we can, in fact, generate a consensus on what camera API standards would most benefit the industry. And what standardization activities result from the exploratory group, if any, will depend on the results of the group discussion. There is no predetermined outcome. This exploratory group is going to start meeting at the end of March and is open to all at no cost. So please consider joining if you are interested. You can go to the Khronos website. There's information there. Next, OpenXR is very relevant to the AR community as it defines a common API that all augmented and virtual reality, and we call that XR collectively, devices and runtimes can expose to application and engine developers. OpenXR, for the first time, enables XR applications to be written once and to run across multiple hardware devices. OpenXR enables device vendors to innovate in the design and the implementation of their hardware and their runtimes, but the industry has now agreed how to consistently expose XR capabilities to software developers to avoid industry fragmentation. And hot off the press news is that OpenXR continues to rapidly gain industry adoption. So conformant implementations now include all of the Windows Mixed Reality headsets, the HoloLens 2, the AR device from Microsoft, Rift S, Quest, and Quest 2 from Oculus, the Vive Cosmos from HTC, And in the last few weeks, Valve has shipped OpenXR for their SteamVR runtime. And Collabora have released a conformant update to their Monado open source OpenXR implementation. And on the software side, the industry leading 3D and AR engines now have OpenXR support. Unreal Engine from Epic was the first, and now Unity has just announced an OpenXR preview. And for the WebXR engine in Chromium, used to bring XR capabilities to the Chrome and Edge browsers, now uses OpenXR as its default backend. And bringing XR capabilities to the web is important. It not only enables many XR use cases, it is also a step towards the connected metaverse in the longer term. And WebXR is being developed by the World Wide Web Consortium, the W3C, who are working closely with Khronos to make sure that WebXR can effectively use OpenXR as a native portability API, saving WebXR from having to be ported to dozens of proprietary runtime APIs. And this is alongside WebXR using Khronos's WebGL API for 3D rendering in the browser. But let's get on to GLTF. GLTF is the Khronos 3D asset format that's focused on being ubiquitous, compact, and easy to process. And so we like to call it the JPEG of 3D, as it is the last mile JPEG equivalent that lets you easily transport and deploy and use your 3D assets wherever you need. And as Martin was saying, even in your PowerPoint presentations. The latest version, GLTF 2.0, uses physically based rendered materials to boost visual realism in a way that is portable to any device and 3D API. Internally, GLTF uses JSON to describe the 3D scene or the asset hierarchy, and uses binary payloads to describe geometry, animations, and skins. You can include textures as JPEG, PNG, or KTX files. KTX is the Khronos texture container, and that includes textures to drive the metallic roughness and specular glossiness appearance of PBR materials. GLTF is a pure file format, and it deliberately does not provide or prescribe any runtime behavior, and this makes GLTF useful to any application or runtime. Adoption of GLTF is now widespread throughout the industry as companies come to realize the efficiency and cost savings of having tools, apps, and engines that can all communicate assets easily to each other. The companies shown here have all implemented GLTF support, tools that generate GLTF assets, and engines and applications that ingest those GLTF models. The GLTF working group is very busy right now. It's actively developing a new generation of PBR extensions that add additional parameters to GLTF 2.0's core PBR materials. The first three new material types are clear coat for varnished objects, sheen for velvet type materials, and transmission for see-through objects. And those three extensions shipped in December, and we have a whole bunch more coming over the next few months. So these extensions are being designed actually by a pretty amazing group of industry experts from Khronos member companies who are doing a great job in guiding the GLTF standard to an optimal sweet spot between materials with high visual realism and widespread deployability, even on mobile devices. So now let's introduce the 3D Commerce Working Group. In fact, much of the GLTF roadmap is being driven by the new 3D Commerce Working Group, which is working to enable the pervasive use of 3D in e-commerce. So the group has realized that the barrier to deploying 3D commerce at industrial scale is the process friction between hundreds of companies trying to cooperate over the design, manufacture, and presentation of thousands of products across multiple platforms. And this is a classic class of problem that industry cooperation and standardization can help to solve. The 3D Commerce Working Group brings together a pretty unique mix of technology and retail companies. And due to its diverse membership, the working group has both real-world insights into 3D commerce challenges and use case requirements, and the technical expertise to create standards and guidelines and tools that will be effective solutions to help make 3D commerce pervasive. For its first round of deliverables, the 3D Commerce Working Group has identified 4 critical problem areas. The first 2, one is holding metadata, and the second is holding multiple product variants in one GLTF file, have catalyzed 2 GLTF extensions that are already shipping. The third deliverable is a set of asset creation guidelines to inform tool and asset designers on how to create 3D assets that can be reliably distributed and viewed throughout the 3D commerce pipeline. The fourth activity is a 3D viewer certification program to enable viewer vendors to demonstrate that they can accurately display 3D commerce assets. And that program is expected to come online in the next few months. So this first wave of activities has been primarily focused on household goods. Looking forward, there is growing interest in enabling 3D commerce for apparel. And so it is likely that the GLTF working group will soon be working on methods to include realistic rendering and animation of cloth materials. So these deliverables show how the work of 3D commerce that is being incentivized and catalyzed by significant commercial opportunities in retail today will also ripple out and benefit the wider AR industry. New GLTF extensions are expanding the capabilities of GLTF, not just for more visually realistic models, but also enabling GLTF to carry metadata for integration into a wide variety of enterprise-level asset management systems. The work to research and clarify and document how to create 3D assets for reliable and pervasive deployment across diverse platforms will save significant time and expense for many companies across the industry and inspire new 3D developer education programs and the evolution of new 3D tooling. This in turn is going to create new commercial opportunities in any market that can benefit from ubiquitous, universal 3D assets, from avatars to GIS systems to engineering data for visualization and many more, and with many of these use cases needing augmented reality deployment. And lastly, the industry's first 3D viewer certification program will provide insights, guidance, and commercial incentives to raise the quality bar for any applications and engines handling and displaying diverse 3D content at runtime. So 3D commerce is really a beachhead commercial opportunity, inspiring levels of engagement and investment that will help move the whole AR and 3D industry forward. So that's the end of my brief overview. I want to hand over now to the other speakers for more details on the latest 3D commerce activities.
Thank you, Neil. I think now we're going to turn to Max Limper. I'm making you presenter at this time.
All right. Yeah, thanks a lot, Christine.
We hear you, and we see your screen. Perfect. Thank you, Max.
So you can see the presentation, right?
Yes.
All right. Okay. Yeah, thanks. So I would like to dive slightly deeper into the topic of asset creation that Neil just mentioned, which is, as he said, one of the 4 areas of focus of the 3D Commerce Group. But our work really could be useful for other areas beyond 3D commerce, because I think it's rather general. And before I dive deeper into the topic, quick introduction about me. I have originally a 3D graphics background, studied computer science, focused on graphics, and did my PhD on how to automatically optimize 3D models for the web and for AR. So basically how to make large 3D models small so we can efficiently use them in all kinds of end user applications. And In that context, I was also researcher and project lead at the Fraunhofer Institute, and we contributed to standards such as X3D and GLTF, for example, to the PBR material model and GLTF 2.0 back in 2016. And that's how I initially got in touch with Khronos. And since then, I'm super excited to be part of this whole effort. So right now, I'm CEO at a company called DGG. We are creators of a software that's called Rapid Compact. And that's a platform that can be used to automatically optimize your 3D models for efficient presentation on the web and in AR. And we also provide consulting services around building like scalable automated 3D pipelines. And at Khronos, I'm co-chair of the 3D asset creation TSG. And as I said, that's one of the 4 focus areas that we just saw. And in that context, we are trying to provide guidelines and best practices and workflows that enable the efficient creation of 3D assets in order to have optimized data that can be efficiently rendered and transmitted across the web. So this is quite important in the context of 3D commerce, but as I said, I believe it's useful for all kinds of applications, including B2B applications such as CAD review scenarios, things like maintenance scenarios in AR, and so on. And the 3D commerce asset creation guidelines have just been released in October last year as version 1.0. You can find them on GitHub, but also as a PDF. And they are really tool agnostic guidelines who can help technical 3D artists who may be familiar with 3D modeling, but not familiar with creating optimized assets for e-commerce, for cross-platform delivery. And we really try to come up with best practices following the input of a lot of 3D solution providers, as well as leading retailers who are working with 3D data already. And another thing that we do is collecting workflow tutorials. I'll give an example on the next slide. And if you would like to get involved, please just get in touch via GitHub. You can look at the guidelines, you can comment, ask questions, and make suggestions via GitHub, or get involved with Khronos, because this will help us a lot to shape these guidelines even more and be like beneficial for everyone in our industry, of course. And so here's just a short workflow tutorial example just to illustrate what we have been working on also during the past few months after the guidelines appeared. So this is a tutorial that shows how to optimize a high resolution model for real-time application. It started with a CAD model of this game controller and then goes through different steps that include, for example, a cleanup of the geometry, where we also remove the interior parts of the model and then create a UV map and create the materials, set them up correctly, and finally export the data to GLTF and review the result in a real-time GLTF viewer that can be used in the browser. So this is basically an end-to-end workflow, starting with the CAD model and then ending up with a real-time version of it, and has been contributed by Michael Badiou from Samsung Research of America. So many thanks to Mike, and you can find it on GitHub right now. But yeah, coming back to the asset creation guidelines that I mentioned and to the workflow, I'd like to give you a quick overview of the process we're addressing. And we have started to basically divide it into different areas that can all be addressed separately. So these are basically different sections where we have different kinds of workflows and tutorials for each of those. And the 3D data that can be optimized through this process for publishing can really come from all kinds of different sources. It can be a 3D scan, can be a CAD model, or can be classical like result of 3D modeling from, let's say, a reference photo of a product. And depending on the product, it may even be a combination. Like, for example, if you have an armchair or so, then maybe you have a CAD model for the hard surface parts, but for the cushions, maybe you don't have a CAD model, but just a sewing pattern or something, and you may model them by hand instead, or use some sculpting tool or whatever tool you'd like to use. So having a 3D model that is representing the geometry. We can then optimize the geometry and topology. This includes operations such as removing these invisible parts like we saw on the previous slide. Then UV unwrapping is a big topic, how to do that efficiently, accounting for things like tiling of texture maps and so on. And naturally then, once we have an unwrapping, we can use textures and PBR materials. And then as a result, we obtain something that we called here a base asset. And we actually saw this on the presentation from Martin, where he talked about one, I think he said physically correct model, right? So starting with a model that is basically perfect in terms of appearance, we can then optimize this model and derive a certain amount of optimized assets for publishing. And this means starting with this base asset, which you can find here in the middle of this graphics, we can automatically derive, for example, a mobile AR version for iOS, one for Android, and they may use different formats, right? You may also use USDZ then in the context of iOS, but then also versions for, let's say, a floor planning tool or a web catalog, and they may all have slightly different requirements. And here we also provide some guidance. So within the guidelines, you can find this table here, where it lists basically for different publishing targets, recommendations regarding the file size, triangle count, number of draw codes, texture resolution. And these are really just rules of thumb. However, they are there like to give you a good idea of the order of magnitude that you should aim for. For example, this 3 megabytes as a maximum file size, it will not hurt if your asset is 5 megabytes. But if it's 30 megabytes, then we can show from the average bandwidth that we used, and can find all the details there in the guidelines, that this may take more than 3 seconds to load on an average device from average user out there. And this is, for example, a rule that you say you don't want the user to wait for more than 3 seconds in an online shopping scenario, because then they may just lose interest and move on. So your asset has to fulfill like this megabyte limit, or at least be in that order of magnitude. And in a similar way, the other numbers are motivated. Of course, they are not carved in stone, and that's also why it's called version 1.0. So as technology evolves, we will also further develop these recommendations. And this is also where we are always interested in hearing your feedback. And yeah, so feel free to check them out and see if that works for your use case. So that was my part already. Looking forward to the panel discussion later and to your questions. And if you'd like to get in touch, please feel free to connect via email or via Twitter. And handing over now to the next presenter.
Thank you very much, Max. It's time for me to make Brent Scannell the presenter. I see that you've unmuted your mic, so that's already great.
Yeah, I think that's working. You see my presentation?
Beautiful.
Great. And it's the right screen this time.
Yes.
Well, thank you, Christine, and thank you for inviting me to be on this panel today and share a little bit about our vision in this interesting set of topics. I'm going to talk today about the influence of 3D commerce and the influence it's had on the evolution of 3D content creation tools. I work in the product management organization in Autodesk, specifically on the 3ds Max product. My role is two-sided. I'm inward-facing in terms of a product owner, where I lead software development teams to solve industry and market problems, as well as outward-facing responsibilities, such as event steering like this one. I like to think that I connect people with purpose. I'm an expert in 3D design systems. I've been doing that for about 20 years, but most of it inside the product design and manufacturing context. Today, one of my responsibilities includes acting as a liaison with the Khronos Group, specifically with the 3D formats and 3D commerce working groups. Prior to Autodesk, I worked for an aerospace OEM in the design organization. I'm a named inventor on 12 US patents related to the work I did there. And I bring with me a lot of, some examples that could have benefited from the technology that we're being discussed today. Some notable examples are things like, building a full-scale helicopter mock-up in plywood to do some usability tests, maintenance simulation, see how long it takes it to replace an engine with a, with a mock-up, pre-flight checks, and even stretching into things like pilot interfaces, where even 10 years ago, the latest and greatest interface was a touchscreen, replacing an analog steam gauge. I don't think it's unreasonable to think that in 2030, pilots will be flying with augmented reality. A little bit of an intro to Autodesk. We help customers who design and make everything from skyscrapers to smart cars, from bridges to blockbuster films. Autodesk makes software for people who make things. If you've ever driven a high-performance sports car, admired a towering skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of Autodesk customers are doing with our software. From tools that you may have heard of already, such as AutoCAD, to specialized tools that are used in visual effects, automotive design, or the latest in manufacturing technology, Autodesk has over 70 active products in the market. All of them play a critical role in design and make across multiple industries. A little bit about Autodesk and XR. So when it comes to AR, VR, or XR in general, our focus is on designers and makers. From the visualization of the future state of a product, adding layers of data that are normally invisible to the naked eye, and even areas such as providing work instructions for manufacturing. We enable designers to see into the future and makers to make a better one. These emerging technologies are a huge part of that desired future state. A little bit about Autodesk and open standards. These are just a few examples of the open standards that are currently in use in design and make tools here at Autodesk. Some of these examples are relatively new for us, such as Universal Scene Description from Pixar, or Open Shading Language from Sony ImageWorks, Material X from ILM, or even GLTF, as you've heard of before, from Khronos Group. Some of these are our own standards, such as the Autodesk Standard Surface. We're working on our muscles, getting up to speed, participating more in these forums, and becoming formal adopters and contributors to these projects. Some of that I want to mention specifically come from the latest and greatest in the Khronos Group, the 3D Commerce and GLTF and 3D Formats working groups. Autodesk joined the Khronos Group in 2019 at about the same time that the 3D Commerce Exploratory Group was formed, and that wasn't a coincidence. This is a group of influential customers who are getting together to discuss and document what's most important for themselves, and it's kind of a product manager's dream. But some other standards that we're also looking at and tightly coupled towards the asset creation side of things are things like Universal Scene Description. We've been very intentional about moving our digital content creation tools to a strategy that leverages USD and Material X in the authoring world and GLTF as a publishing format. And just taking a moment to talk a little bit more about Material X, it's of particular interest to us for some of the reasons that Martin's already shared, and I won't go into all the technical details, but we're converging on using the Autodesk Standard Surface and Open Shading Language contained within a Material X description document as the de facto standard here at Autodesk. Aligning on a standardized material description and computer graphics will accelerate all future development. And it should not come as a surprise that the folks working on these initiatives, Material X, OSL, Standard Surface, they're all deeply involved in the PBR Next initiative in the 3D Formats group. So how is all this being influenced? What's the influence of 3D commerce on our development? Design and make is the core part of our business. Customers in the retail space are demanding more photorealism to accurately represent their products. The challenges raised by these customers are important ones that stretch way beyond retail. Some of these were just presented by Max. The growth in this segment is impressive and it's having a broad impact. In the retail world, customer expectations are evolving, from illustrated catalogs 100 years ago to shopping in AR today to immersive experiences tomorrow. The tools to create these visualizations must evolve in kind. As catalogs and inventory go digital, the demand for content skyrockets. For products like 3ds Max and Maya here at Autodesk, this represents an enormous opportunity, but also an incredible challenge. Collaboration challenges. As teams scale, so do their problems. Making sure different pipelines play well together has never been more important. The content boom in retail is happening, and it's sink or swim time. Martin shared a great example of bringing one piece of data across multiple products and try to ensure the fidelity and intent is preserved all the way through. Physically accurate rendering is crucial. The work done in the PBR Next initiative is driving important material changes for authoring workflows across all industries. Things like Material X are being adopted by all of our tools today. Publishing formats. Adopting these modern publisher formats is no longer optional. Our customers demand this of us. And probably the most important impact is open forums. We've never participated in these open forums as much as we do today. It's so important for us to stay connected with our customers and develop solutions together, rather than following and adopting after the fact or hoping that our customers follow us. So what does the future look like? I'm not really sure, to be honest. For me, one day I hope I'll be retired, maybe on a boat somewhere, but for XR in general, I'm sure about a few things. Collaboration will happen in a connected ecosystem, likely leveraging open standards like USD and MaterialX. Whether this is an immersive design review, planning sessions, or even peer-to-peer feedback. What's more, I'm confident that the collaboration challenges that retail organizations will face as a result of this content boom will catalyze important innovation from technology vendors such as Autodesk. The visual fidelity of what we see will continue to edge into the convincing and the real, likely leveraging improvements to physically based rendering and its support in formats like GLTF and real-time renderers that are supporting them. Going back into a little into the AR for enterprise space, I would not be surprised in the slightest if the next big leap in something like harmonizing how 2D text and graphics are displayed in AR or consuming IoT data comes from a group such as the members on this panel today. Thank you. And with that, I think I'll pass it on to our last panelist, Ashley.
Thank you, Brent. Yes, you're right. Ashley is the presenter now, and we're waiting to see, and we have her screen. Thank you, Ashley.
Great. Thank you so much. Yeah, hi, my name is Ashley Crowder. I'm the co-founder and CEO of Ventana. I've been working in the 3D XR space for about 15 years, got my bachelor's and master's engineering, have 14 patents in the space. And I'm just so excited for this watershed moment that's really happening with this technology adoption. The Khronos Group has been a huge impetus for this, as having standards for 3D, as we've talked about, is essential to enable 3D at scale. At Ventana, we're trying to help streamline 3D workflows as much as possible so businesses can leverage their 3D designs across the entire enterprise. We do this through patented algorithms that automatically prepare and optimize 3D for every visualization scenario, housed in a cloud content management system. So it's easy to collaborate, QA, and deploy 3D at scale. One of the reasons this is needed is because product design programs did not meet web, social, or game engine standards, leading to a huge disconnect across the retail value chain. Clothing, footwear, bags, furniture, and other consumer goods are all designed for manufacturing in programs like Browseware, Clo, Moto, Keyshot, and other 3D software programs, as mentioned from Autodesk as well. These are huge files with every detail for manufacturing that just do not meet these standards, making it extremely difficult to share them to internal and external stakeholders throughout the product development and sales process. This is a huge deal because 3D is no longer optional. Just like video is standard today, having 3D as a part of your storefront is soon going to be mandatory because it's driving real results, doubling online conversion rates while reducing returns by 40% because it gives consumers such a better understanding of the product. We're also seeing an average of 85-second dwell time, almost double of image ads, and a 33% click-through rate to purchase. This is real money to the bottom line. And it's not just B2C. We're also seeing these significant increases in sales for B2B as well. COVID obviously expedited this as it shut down sales travel and delayed sample deliveries. We worked with our clients to create advanced virtual showrooms with photorealistic 3D visualizations that proved you can sell wholesale digitally. This is an enormous step forward for the apparel, footwear, and consumer goods industry, as it enables us to fully replace physical prototypes with digital. There are huge cost savings implications because samples are usually 3x the normal unit cost plus shipping. This in turn reduces carbon footprint, which is also a real cost for companies in Europe that pay for carbon credits. Of course, sending a digital file is much faster, so you're speeding up time to market. And lastly, because it's digital, you can still make changes and do product testing, which I'll get into in a bit. At the end of the day, you're increasing sales and speed to market. As you saw in some of the earlier slides, the retail value chain is a bit of a spider web. As you saw in the earlier slides, The retail value chain is a bit of a spider web. B2B sales require decisions across a multitude of internal and external stakeholders. Without a 3D standard, every person who wants to view the 3D model would need the 3D software that was used to make it. I had 5 logos on my earlier slide, but there are over 50 plus 3D programs that are used. And higher up decision makers are not trained on any of these software programs, so this is not an option. Instead, what's happening is 3D artists are taking screenshots and sending PowerPoints or PDFs, resulting in an endless email chain of notes. 3D web viewers are required, so anyone, no matter their skill level in 3D, can just view and comment on the 3D design. With GLTF and WebGL, it's as easy as sending someone a link and allowing them to just drop a pin and make a note right on the model. We also have clients using 3D for product testing. Mesh One is a product testing company for brands like Nike, The North Face, Lululemon, and more. We've partnered to enable digital testing with 3D. So before heavy investment is made in tooling and molds, brands can get significant feedback to tweak their designs before production. We've just started, but the benefits are huge. The number of variants you can test is almost infinite, as long as the testers are happy at their computers. You can also get way more diverse group of testers from around the world because you're not constrained by shipping product. And of course, it's a much faster turnaround. Physical product testing, is not going to completely go away, but with 3D, it can significantly be reduced. Khronos Group standards are helping enable this at scale. GLTF and WebGL are enabling us to deploy 3D across a huge array of devices through the web and mobile. Vulkan standards are helping with augmented reality, which is extremely important to see products true to size and environments. And OpenXR is making AR and VR applications portable across devices, as you heard, so we can continue to push the boundaries of immersive try-on experiences. Khlo is one of the 3D apparel design programs, and they're actually now using the KHR material sheen extension to get more realistic fabric on the web. So it appropriately reflects the lighting bouncing off the fabric. And this is another, GLTF and PowerPoint, which is pretty cool. Browseware, Khlo, and OptiText are the main apparel design programs, which all store multiple colorways, which is really next in line for the roadmap. Because these colorways are not just materials, but also geometry. So for example, this blue shirt could be one Browseware file with 6 different colorways, one for each pattern, with and without the pocket. The KHR materials variants will allow us to create efficient configurators for both materials and this geometry change, so we can store less files overall, leading to faster load times and better user experience. In order to further the product testing with 3D digital files, we'll need standards around animation and fabric physics, as well as fit and sizing, which is on the group's roadmap. Taking this one step further, we're talking to original design manufacturers who also want to use 3D scanning to scan products in the manufacturing line, actually compare to the approved original 3D design for quality control. Having standards for point cloud data will help expedite this type of QA significantly, which is also in the group's roadmap. My email is ashley@ventana.com if you have any questions, but I'm going to turn it over to Christine for the panel.
Thank you, Ashley. Yes, and thank you also for showing the slide with all the panelists' names. I want to start off by thanking everybody for these fantastic presentations. And clearly, there's just been a lot of work that's been done in the standards, in this group, in the 3D Commerce group, as well as in Khronos as a whole. One of the challenges I think that face many people when they're thinking about how to use standards is how mature they are, or at what stage is the right stage to start adopting, or I guess it comes down to what is the right stage? Is when will all these standards be available, and when do people know how to how to get in, where to get started. Could we start with that? How to get started? Neil, you have a lot of experience with this.
Yeah, I think the whole pipeline of creating standards is, one of the cardinal rules is don't try to standardize stuff too early. Wait until a lot of the best practices have actually been established by the early adopters of a new technology. And when you're not having to do research and development by committee, which is not recommended, that's the right time to create the standards. And I think now in this area, I think we are in a good position. There is a lot of now established practice around creating models and deploying them. There's still more to learn, but we already have a baseline that's adding significant value to a bunch of companies out there in the industry. And the question, when's the right time to start using these standards? I think the answer for many of them is right now. I think you can look at the adoption curves of GLTF, the work that 3D Commerce is doing to push GLTF forward, OpenXR, WebGL, all of these standards are now being deployed in significant volume throughout the industry. So, come on in. The water is good.
But wait a minute. So, if you were to, for example, if a company said, "Okay, we think it's time to start adopting OpenXR," does that compete with ARKit and AR Core? Can you compare and contrast those?
Yeah. So, and actually, that's a great example of what I'm talking about. The the ARKit and AR Core, there, as people probably know, they're the proprietary AR APIs from Google and Apple for mobile phones, and both of those companies are doing really awesome work to figure out what mobile phones can do in terms of augmented reality, and delivering those mobile phone capabilities to developers in APIs that are pretty high level, easy to use, and you can see the good results. People beginning to use those in really interesting application areas. So it's Google and Apple that are kind of pushing the boundary and doing the R&D. But of course, they are both proprietary APIs, and they're different. So if you want to take your mobile AR app from one maker phone to another, you have to rewrite your app. I think we'll soon be reaching the point where people will demand that their XR mobile applications, will want, including AR, will want to be portable across multiple devices, not just mobile phones soon, as Martin was saying. We're about to get much more immersive, spatially aware devices. Is not just going to be mobile phones anymore. And at that point, the need for portability becomes critical. And I think OpenXR is well positioned to become that, what ARKit and AR Core can evolve into. All the good work that Google and Apple are doing around understanding the environment and inserting 3D objects into a spatially understood environment with occlusion and proper lighting. I think OpenXR is perfectly positioned to evolve into the cross-platform open standard version of that style of API.
Well, and this is always a challenge, right? The proprietary landscape and the standards working in tandem, I guess. And the same comparison could be drawn, or at least the issue with GLTF, and that if you use GLTF, what about Apple and USDZ if you want to deploy mobile devices? Is there somebody on the panel that's knowledgeable to speak about that?
Sure, I can chime in. I mean, when we work with our clients, we always try and push them to focus on GLTF, because once you have that, there's a lot of different conversion services out there to convert that to USDZ. But web is kind of number one, right? If you can just display this on the web, it's easy to share. And then kind of going back to your first question, we tell everyone, start adopting these standards as soon as possible, because once you set up a 3D workflow within your organization, it's really hard to change it. So the sooner you can kind of start, the better.
I would like to also add on that, if that's okay. So I think GLTF is a great deployment format, and that's how we designed it back in 2015, 2016, like GL transmission format. And USD is actually by far more than that. So USD is a loss-free format that can store like references between scenes and so on. So there's a great conversation right now in the industry about adopting USD as an asset exchange format, whereas having USDZ and GLTF as delivery formats. And in that sense, having a loss-free format like USD as a basis is very interesting, and then transcoding to different delivery formats. But naturally, if you store GLTF in a loss-free or almost loss-free way, like not using Draco compression in a lossy way or whatever, then you can also use it as a basis. But for example, at the Khronos Asset Creation Group, we have always been agnostic about this format that we use for this high quality asset that we call base asset, and that Martin also mentioned in his presentation, and only decide for the final format, for the delivery format at the very end when optimizing for the publishing targets. But the guidelines that we have are basically agnostic regarding this format.
You just mentioned about compression, and someone asked if Khronos will still work with binomial as the basis for compression support.
Mm-hmm. Yes, so definitely. I don't know. Maybe Neil wants to say something about it, or someone else.
Sure, and I can mention it, but feel free to add on, Max. Yes, no, absolutely. Of course, for assets that need to be transmitted to small devices across the web, in fact, transmitted anywhere, small asset sizes can be very enabling and important. So we have had geometry compression for a while using the Draco technology that was contributed to GLTF by Google. And we are working very hard on leveraging the binomial basis universal compression technology for textures. And we're going to be rolling out a coherent set of extensions, tools, and guidelines at any moment now. You heard it here first. And it's a really interesting technology. It's a way that you can encode your textures into a compact format, and it can be, once it hits the client device, the end user device, it can be very efficiently transcoded into GPU accelerated texture formats, which means not only are you transmitting a small asset across the web, you are unpacking it into a very compact on device memory footprint. So you don't have to expand your textures into a full-size image, which is what you have to do if you use JPEG or PNG, for example. So all of that pipeline around compressed textures should be rolling out in the next few weeks, actually.
Fantastic. That's great to hear. I think that we should maybe get into a little bit of the 3D commerce questions. So, there are two questions that are interrelated. Why did a group of companies interested in 3D commerce begin working in the Khronos group, and what makes it so active? It's exciting. You guys are all on board. What's the secret sauce? Timing? Was it a question of timing? Was it a question of who else was already in the club?
I mean, I think for us, who was already in the club was a big factor in that play. You know, we were a lot of these customers who were making content for the retail space in a digital world were already using a lot of our products, and you know, we started to see maybe before even they did that a lot of these problems they were having them in common, and the Khronos group provides this amazing opportunity to kind of, you know, leave our competitive baggage at the door and come together and discuss, you know, the low-level problems that we all have in common. And that's what's kind of really, really interesting about how this group came to be, why it's so interesting for us, and you know, just observing what all these you know, players in the same space have in common, and then you know, deciding to work together to solve them is incredible.
I'd like to see more of that everywhere. Martin, did you want to have you? I see that you.
I might be able to add to this. The whole idea started, I think it was the spring 2018 or something like that, with a small group of retailers where all of us are competitors. We were part of that too, and then a big meeting in San Francisco in September 2018, I think, and then that group then connected, I think, to you, Neil, and Khronos. I think we had a finger in that game and maybe pointed at you, but the whole group looked into different ways of doing what we wanted to do together, and that's when it took off. And I guess it started in 2019 then. Neil, you have to correct me if I'm wrong. And for us, IKEA, it's coming back to your question. When do you start? When do you start using these open standards? Yeah, for us, we have been like trying to use like internally even only 10, 12 different file formats. So just aligning internally to one or two is a big leap forward. So it was an easy way of doing it, and then trying to get everybody else to join in when we got all the others on board. And I think that started it all. And I think all my colleagues in the retail space are in the same problem as we do. We don't really earn money selling 3D content like the game guys and the movie guys do. They live on what they produce with 3D. We live on this is extra work for us. We just want this to work, and using anything like standardized to do it.
Thank
and
you.
Neil, you talked to more with all of them in individual talks. I think I'm speaking for all of them when I'm saying this, or did they have other reasons to join, Neil?
No, I think you summarized it good. I think the Khronos was the natural place to come because we have some long-term experience in 3D, so it was kind of maybe the first place to think of. But I think the 3D Commerce Working Group really shows the way forward. I mean, it really is it's the dream working group in many ways, because over the many years that we were doing OpenGL, 20 years ago, when we were doing OpenGL, it was really hard to actually get the developers to come to the meetings to tell us what they actually wanted. And so the danger is you just get a set of hardware companies, you know, sitting around in an ivory tower trying to guess what the real problems are in the world. And we've improved over the years. Vulkan is much more informed from the developer community than OpenGL ever was. But the 3D Commerce Working Group is totally awesome, because we have as Martin just said, now the people that really need this stuff to just work, their real world problems, you know, knocking at the door, coming into the working group and really helping us understand what the problems are, so we can work together to solve them. You know, this is a great model that we should, you know, aim to emulate in other working groups as far as possible.
There's a question also, in fact, about the embedded camera exploratory group, where there isn't something that exists before, as there was with the 3D commerce, but there is this partnership with the embedded, this machine vision group. Can anybody participate in the exploratory group level, or do you have to be a Khronos member first?
Yeah, I can talk to that too. Actually, now thank you for reminding me. I think another reason why the 3D Commerce Working Group got kicked off successfully, it started in a positive way and it managed to generate a quorum in the industry, is that we used the same exploratory group process that we are now using for the embedded camera API. And it's basically everyone is invited. No cost. You don't have to join Khronos. You can just come to the discussion and figure out whether the industry is ready and does it know what it wants to do to work together to solve industry problems. That turned out to be a really positive experience, I think, for everyone working in 3D Commerce Working Group.
But then they have to join in order, once the exploratory group converts to a working group to work on the specification,
yes.
then membership is required.
Yes, because we need people to come in under the IP framework. Once detailed designs start, and we need the membership fees to do all of this stuff. We are a non-profit, but no, it does cost to get this stuff done. So the membership fees help cover that.
Well, I want to just transition a little bit to how Khronos does its development, both at the community level and in the IPR safe zones. There's other activities in other standards organizations, as we know. Khronos, maybe there's some overlap with other organizations like Material X and USD. What about OpenXR and WebXR? These are a little tricky for people who are not members and working in the trenches. Can you explain those, Neil, please?
Yeah. So the key thing here is no one standards organization can possibly solve every problem in the world. And so it's important that every standards organization, and then there are many standards organizations and many awesome standard organizations throughout the world. And it's important that the different standards organizations know what their own area of expertise in and the value that they can provide, and be careful to coordinate with the other organizations that are doing adjacent work. And some of the standards that Brent was mentioning, Material X, for example, and USD, they're excellent examples of fantastic work that's going on in other organizations that Khronos can definitely leverage. Now, we don't want to reinvent those wheels. Life is too short to duplicate that kind of work, and they're doing a great job. There's no need to try and reinvent it. What we need to do, though, is to make sure that the standards that we're creating work well with those standards. My favorite word, you'll laugh, Christine, the constellation of standards it's going to take to truly make augmented reality pervasive. It's going to be hundreds of these standards once you've added them all up. But Brent,
I think that there are different levels of specificity. There are different levels in the stack, in the computational stack, and
yes, that's right. Different levels in the stack, different use cases, and different markets.
Exactly.
It's a grid of standards that we need. But Brent, I'm interested. I mean, do you think, are we doing a well enough job here? Do we need more coordination with folks like USD and Material X?
Well, I mean, I think you nailed it on the head. Nobody wants to do anything twice or reinvent the wheel. I think if you start to split some of these things out by purpose, kind of like I alluded to, on the authoring side, using some standards like USD Material X, and doing things that are really good at publishing, like GLTF, helps draw the line, when you want to use one or the other. But for technology vendors, for adopters, for customers, they don't want to have two different pipelines or two different workflows to get their end result done. They just want it to work. So I think in some ways, some of these will naturally, coalesce and again, align. But we have to pay attention to where misalignments start to happen, and proactively start to bring those things back together if we do start to observe. That's not the role of any individual member of any of these groups, but kind of the community as a whole that are using both standards to raise awareness when things start to misalign.
That's a really good point. I want to ask Max, in your introduction, you mentioned that you've worked in the past on, I think, manufacturing and enterprise use cases. Can you share how you see adoption of standards as improving productivity, efficiency, metrics that matter to large enterprise? Sort of the AREA audience? Yes?
Sure. Yeah, I mean, we've worked with, for example, like AR and 3D for after sales and use cases like that. And I think they are highly connected with what we're doing in 3D commerce, because when you're trying to serve all kinds of different platforms, but also when you're trying to optimize data for even one real-time use case, it's very valuable if you can have a standard for the input and output, ideally, of your pipeline, right? And that's basically also what Ashley showed during her presentation, that serving, no matter if it's like, say, apparel, or if it's furniture, or if it's CAD data that you're processing, like in the end, the time that you need to process your content and do all this data massage, like to get the materials in the right format, like that's still a big pain, right? But the time needed for this data massage is just like the main cost driver, I believe. That's the biggest problem. And if you can just reduce that time by different tools outputting the same formats and like serving data in the same way, or similar way at least, then that's already a huge cost saver. So I think that that's the main benefit of standards, that you save time for stupid, like dumb data massage tasks, like converting from format A to B. Exactly. Yeah. But that's basically what we saw in different presentations today, right? Like reducing the time needed for like to get your data in the right format, and doing this without data loss, and doing it automatically. So that's the main benefit, and that's a huge cost saver.
And that's for the customers potentially, or those who are providing services to the customers. Your company, and if I'm not mistaken, Ashley, you're quite small companies. Do you see a benefit to you? What is the benefit? Otherwise, you wouldn't be doing it, to being involved in standardization at this stage. You know, wouldn't you prefer to wait until it's all been standardized and you can come in and pick up what's done by others? Ashley, you want to start with that?
Sure, yeah. I mean, I think, you know, for us, just to repeat, you know, we don't want to reinvent the wheel. And as you said, you know, we're a startup, we have limited resources. We want to be spending our time solving the hard problems that are going to move the needle forward that other people aren't already solving, right? And we want to help push these standards forward, because it's really the only way these end use cases can happen. I mean, Auto International we work with, they launch 80,000 products a year. The only way to do something at that scale is to have standards. And so, yeah, we're so happy to be a part of the group, because it allows us to kind of see what's available today, where the roadmap's going, and so we can better design our product for the future.
Yeah, same. Basically, there's no way for us to wait until everyone, like, you know, there's this crossing the chasm, this idea that you can categorize the industry like into different like levels of adoption, and then the last like waiting for the laggards, how it's called there in this model. This will take like, I don't know, a couple of years until like 10 years or what, until everyone embraces really GLTF. And for us as a startup, that's just no perspective, right? Like we are working with the innovators and the early adopters, and try to build sustainable pipelines that will still be valuable in 10 years, instead of doing a lot of manual work that will not be valuable anymore in a few years, because everyone's adopting the standards. So the earlier, the better.
Thank you. Neil, did you want to chime in or summarize? I think we're kind of reaching the end of our time. Is that?
Yeah. So I was just going to mention that I think it's awesome that standards benefit companies of all sizes. I mean, we have Autodesk and NVIDIA and IKEA here. They're larger companies who want to build, see people building out solutions at scale. That's good for all of our business. But one of the key things about standards, it helps the smaller companies too, because it removes the barriers to smaller companies having to solve every problem before they can start adding their own unique value. So I think it's great, that we have the range of companies from large to small. But yes, summarizing, I think hopefully people have found this useful. I find it fascinating that, as I was kind of saying in my presentation, that yes, we've talked about 3D commerce and how we're being pretty focused on solving real world problems, but hopefully people have seen how the class of problems we're trying to solve in 3D commerce, with the good incentive to get these problems worked on, is going to ripple out and benefit
For sure.
all kinds of other.
I can see, it's not in commerce, but like if you're doing manufacturing and you need to have those PBR materials and on the models that are used, and many of the features that are being worked on for the asset creation will help in other use cases, not just retail.
Exactly. So 3D commerce is one specific vertical, but the solutions we're coming up with are quite general purpose. So yeah, hopefully that's come across.
Yes, it did. I'd like to thank everybody for your fantastic contributions and great discussion. Thank you also to attendees for staying with us for what is a little bit longer webinar than usual. I hope you found it valuable. I will be publishing this archive to the AREA YouTube channel and make it available to you. I'll be sending that out, and we'll be sharing it through social media. Once again, delighted that the AREA and Khronos group have established our liaison, and look forward to working together more closely going forward. Thanks, everybody.
Great. Thank you, Christine.
Thank you.
Thank you.
Bye-bye.